Hey everybody. 5.1 Graphing the Trigonometric Functions. This is one of my favorite lessons in trigonometry because I love graphing and it's so fun the way this book has been presented. We've only talked about the right triangle kind of trig and basically dealing with triangles. Then we translate to the unit circle, which you heard a little lesson in 4.1 about, and you guys were asked to create this unit circle here. So now we're going to translate the unit circle and these various trig functions onto a graph in the xy plane. So what you do, I think the best way is to always remember when graphing, if you ever get stuck, you can always plug in, make a table. So actually, let's do theta, and then I want to graph cosine theta because the book does sine theta, so you can look in the book for sine theta. And then helpful inputs for theta wouldn't be like 0, 1, 2, 3, 4. We would actually want to think about radians in this case. We could also do degrees too. But what is 0 degrees or 0 radians? Well, what's the cosine of 0? And in that case, you would just look over here. Remember, and this is what the book's description, this is the first time they actually show the unit circle, but since we've kind of gotten familiar with it, remember the x has to do with cosine and the y has to do with sine. So there's my y and there's my x because it's over r, but 1 is our radius. Remember, this is equal to r. So we know that the cosine of 0, what is the x value at this point in the unit circle? The x value is 1. Okay, then if I graph the next one, I could do pi over 6. So we have pi over 6. Well, what's the cosine of pi over 6? Go to the unit circle right here. And what's the x value? It's the square root of 3 over 2. Now the square root of 3 over 2 is approximately 0.87. So it's kind of nice when you're graphing to kind of have an awareness that that's around the 0.87 mark, okay? And then if we did pi over 4, that would be the cosine of pi over 4. What's the x value there? Well, it's root 2 over 2, which is approximately equal to 0.71, so 7/10, really close to that. So pi over 3, cosine of pi over 3 would be 1/2. You can see that. Cosine of pi over 2, if I input pi over 2, that means, and I'll just write it out a couple more times, that's equivalent to 0. Remember, that's the x value for pi over 2. Cosine of 2 pi over 3 is negative 1/2. So let's just continue this up here so we can do it. So here's our theta. This is our output is cosine theta. So 2 pi over 3 is negative 1/2. 3 pi over 4 is negative root 2 over 2. And remember, that just means it's negative 0.7. And then I'm just going to skip to the quarters. So pi would be negative 1. 5 pi over 4 would be negative root 2 over 2 again, which is negative 0.7. 3 pi over 2. I'm not doing the thirds anymore, but you get the picture. You could include the threes or the thirds is 0. And then we've got 7 pi over 4 is root 2 over 2, which is approximately 0.7 again. So what we do is we translate this onto the xy plane, and I'm going to show you a couple of ways to think about this. This axis is theta because in a table of values, the first column is usually the x-axis. So instead of the x, we're saying it's theta. On this axis, well, think about it. If we're dealing with the unit circle, notice that all of these outputs, what's the largest this output's going to get? We've got 1, 0.8, 0.7, 1/2, 0, negative 1/2, negative 1. So that's the smallest it's going to get, and 0.7. So this is really important with a cosine graph and a sine graph, that the greatest it's going to get is 1, the smallest it's going to get is -1. Remember, we're looking at the unit circle where the radius here from 0 or from the origin up to any point is 1. Okay, so that's the farthest it's going to get away from this graph. Now, if we start with 0 for theta, that's here, but it's up on, it's 0, 1 is our first point. So 0, 1. What I'm going to do is I'm going to go to 2 pi radians because that's what we did here. And I'm going to break it up. So halfway between 2 pi is pi. So if I start here, here's 0. Halfway is pi. All the way around is back to 2 pi. So really at 2 pi, and I didn't write this, but if you look at 2 pi, it should also be 1. So basically you're completing your cycle right there at 2 pi. So this point right here would be 2 pi comma 1. Now, if we look at the other points in between, I just break it down this way. So half of pi is pi over 2. Here's half of, between pi and 2 pi, you could go pi over 2, 2 pi over 2, which is pi, 3 pi over 2, which is right here, 3 pi over 2, and then 2 pi. And then halfway between that, that's pi over 4. Here's 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So I'm not even going to include the pi over 6 and the pi over 3, but does everybody understand that that's pi over 4 is before you get to pi over 6. So we could put pi over 6. We don't usually use the pi over 6 and the pi over 3. It just starts to get a little busy. So I focus on the quarter rotations. And now when I graph it, so let's get an even different color. So here's the first point using my table of values. I'm using this part. Now if I do pi over 6, that's 0.87. So here's 1, here's 0.5. So 0.87 would be somewhere up here, right? Then pi over 3. Oh, and we should have done pi over 4. Oh yes, so pi over 4 corresponds to 0.71. So pi over 4 is here, go up to 0.7. That looks like about right here. Pi over 3 would be, which is in between pi over 4 and pi over 3 about right here, is going to be 1/2. So here we are right here. And then pi over 2 is down to 0. Okay? So I put some links to some like some actual live animations of this online, and I highly recommend you watch these. They're very helpful. So then we have we're going down beyond pi over 2. We're up at 0. So we're up here right now. Now we're going to go to 3 pi over 4 and 2 pi over 3. You can look at it. It's -1/2. So do you see the symmetry at this? 3 pi over 4 is equal to 0.07, so that's right here. And then we're going to get to pi. Pi is -1, so we like nice numbers like that. Pi is -1. Okay, so then if we move on, we've got 5 pi over 2, which we decided was, whoops, I think that's 5 pi over 4 actually, not 5 pi over 2. So 5 pi over 4, we're going back up. That's around -0.7. See how that's equal across? And then 3 pi over 2 is back at 0. And then 7 pi over 4, so now I'm jumping over here. I'm skipping the pi over 3's, but 7 pi over 4 is close to 0.7 again, so we're going back up here, not quite to 1, but really close, and then that 2 pi corresponds to 1. Remember, these are all the x values in the unit circle that we're looking at. Okay, so I'm basically graphing the x value and the angle that corresponds to that. So now we get to connect the dots like this. All right, so we're graphing it. Here we go. And that is one full period of cosine. And a period is the time it takes the graph to get back to where it started. So see how it starts at 1 and it ends at 1. So now I want to show you on your graphing calculator. First, make sure that you're in radian mode because we're going to deal with the radians. You can do this with degrees too, but we mostly use radians. So if we graph cosine, cosine x, but it's really thinking of theta. It's still an input. And you just hit a random graph. I'm going to just say that we're in a standard window. So you can kind of see the graph. But now our axis, this is from -10 to 10. That's what the window is. So if you change your window, there's a cool thing called zoom trig. So you hit the zoom button and then you hit number 7. And that window goes from -2 pi to +2 pi. So it gives you that range. So now do you see that on the right of that graph up there, we're going from 0 to 2 pi, and that does finish that cycle there. So now what I'd like to show you is something that you may have seen in Algebra 2, which I hope you have, but if you haven't, it's not the end of the world. You'll see it when you take pre-calculus. But what happens to this graph if I perform some other transformations to it? So for instance, if I take and put a 2 in front of cosine x, so let's look and see what that graph is doing. And then I'll kind of summarize all of these translations. Okay, so another cool feature in your graph is the table. So you have to hit the second button and the table. And I want to just show you that you can actually come up with a table of values. If you go to table set, and I'm going to start at 0, and what I did for my table is I said I want my steps to go every pi over 4 increment. So you can do second pi divided by 4, okay? And you're going to ask the independent variable. That means the input, or not ask, you're going to have the calculator do the auto. So it does the work for you. You don't have to ask it anything. And it also spits out the output. So what we're going to do is we're going to go back to our table and we're going to look at our values. Now, y1, if you remember, y1 was just cosine x, y2 is 2 cosine x. So what happens to your table of values? If x, which is, remember the angle, is 0, cosine of 0 is 1, but 2 cosine of 0 is 2. And for the next one, so we said we did pi over 4, so 7.7854 is around pi over 4. So you've got this value 0.7, right? It looks like it's doubling, right? This value y in the y2 column is doubling. The next one would be pi over 2. It's 0 and 0 because if you do 2 times 0, you get 0. So the next one would be 3 pi over 4. This right here, we're at -0.7, and now look at its doubling. So what happens to a graph when you put a 2 or a number, a positive number out front that's greater than 1? It's called a vertical stretch. So it stretches out the graph. So now let's look at something. I want to show you what happens when you have a negative in front. So you got a negative, and here is cosine. So we've got cosine of x. What do you think might happen? Well, first before we look at the graph, I want to look at the table. So let's look at these tables. Oh, interesting. So if you input the angle, you get out a 1. That's the original one. That's what we generated on our table. But now everything is negative. So all of our y's are the opposite of what we had before. Okay? So if we graph negative cosine x, and I'm going to graph it right on the same set right here. I'm going to say, okay, here's 0 at cosine. So this is the graph right here of y equals negative cosine x. Okay, so instead here, everything's opposite. So we can say, if we sketch this, that it's reflected about the x-axis, or the theta axis. So we're going to graph it like this. All right, so it's a reflection about the x-axis. Okay, so if we have y equals cosine x, and I'm just looking at this one, transformations that can happen, and this is a quick lesson in pre-calculus, and you'll see this again in pre-calculus, like I said, but the idea, if you have 2 in front of a function, that's what's known as a vertical stretch. This stretches all the y values. So basically, if you have a graph, like we said, here's cosine of x. Instead, it's going to say, okay, well now everything's double. So x-intercepts are preserved. So it just stretches it out. Think about it as a vertical stretch, okay? Because there will be a horizontal stretch and compression in your future math career. Now, if you have a negative out front of your function, and so like this would be a function, if you guys remember function notation, just for those of you who are looking, if you have a negative in front of a function, that's called a reflection about the x-axis, and all the y values take the opposite sign of what they were. So here's our original cosine graph like this, and instead we're going to reflect it, and it goes down here. And once again, actually, that the x-intercepts stay the same. The x-intercepts on this axis right here, x or theta. I'll say x or theta, so just be aware of that. So now I typed in -2 cosine x, so that's a double combo. So we've got this graph. If we look at it, here's the original cosine x graph. And now that -2, what's that going to do? Well, it's a reflection about the x-axis plus a stretch. And you can play around with this on your calculator. Remember that feature zoom trig to get that window that you want. And with that, you can also just even narrow it down from 0 to 2 pi. So this is kind of an introduction. I wanted you guys to just look at it, and I'll talk about the other graphs too, and I'll continue to. This is just the beginning of the graphs. You have to do numbers 1 through 12, and those are small transformations on the original graphs. So you can look up the original graphs, you can go online. I also put some really good lessons on how to graph all of them. It derives all of them, and then those animations that I highly recommend you watch. Here's the graph of sine theta, and this is in your book, and you can see it. And it's kind of nice. It shows the different areas that correspond. So if I actually were to fill in points right here, this one at pi over 6, well, what is pi over 6 equal to? Pi over 6 is equal to 1/2, because now we're dealing with sine. So remember, sine is all of the y values. So now you're going to graph this, all of these y values that correspond to the pi over 6, the pi over 4. So these are your inputs, and these right here are your outputs. So you can just verify. At 0, we have the sine of 0 is 0. At pi over 6, the sine of pi over 6 is 1/2. And look, the sine of pi over 2 up here is 1. So that's when we reach our maximum of this graph. Notice that we're have an x-intercept at pi, so that's because when we get back and do half a rotation of our circle, we're down to pi. Notice down here, 3 pi over 2, that's right here, that it's down to -1, so this is the minimum for -1. And then we complete this rotation to 2 pi. I'm not going to get into the negative values, but basically it's symmetry. It just continues on. So I'll try to draw pretty, but you just continue on and the values are the same. If you go in the negative direction, you're going backwards. So you've got from here, now you're at negative pi over 6. And where are you at negative pi over 6? You're right down, it's equivalent to 11 pi over 6. So 11 pi over 6 is at -1/2. So by symmetry, you can see that it just continues on with these points. So the graph just, it's a periodic thing, so it continues. So the period of this, it completes, it returns and does one full rotation in 2 pi radians. I wanted to point out tangent, and all of these are in the book. It's kind of bare minimum on the explanation. So if you have tangent theta, remember in the unit circle, tangent theta is equal to the ratio of y over x. So if you recall, this actually is equivalent to the sine over cosine. Y over x, if you look at this, when do you have x values that are undefined? We're going to have x values that are undefined at pi over 2 and 3 pi over 2. Okay, so if we're just looking at from 0 to 2 pi here, I can see that this is undefined. That's because, think about it, if you have tangent of pi over 2 and you plug in the y value, you've got 1 over 0. This is undefined. Graphically, what that often means is that means that that's a vertical asymptote. So you're going to have a vertical asymptote where it's undefined, and that will happen for all the trig functions. That's going to be the same for cosecant and secant, and I'll tell you about that in a second. So that you can draw these vertical asymptotes, which they did. This is at x equals pi over 2, it's a vertical line. Here's x equals 3 pi over 2 at the vertical line. Now to find the other values, you just have to do some of the ratios. Remember that tangent of pi over 4 is just equal to root 2 over 2 over root 2 over 2, which is equal to 1. So that's a nice value to use, and that's what I always tell my students to look for. This value is pi over 4. If I were to label it, be pi over 4 comma 1. And then you can study the behavior near pi over 2, but the idea is that it's approaching this, but it will never touch it because it can never actually equal it. Going to in this direction, negative pi over 2 is also a vertical asymptote, because that would just be going from here in the unit circle down to this direction. So negative pi over 2 is a vertical asymptote, and as it approaches, it gets really, really negative. We could look at something like pi over 3, but that's not even close. How about a table? So let's look at a table, and if we graph tangent of x, and I want to just study this table, and in this case you can see the error. The error occurs at pi over 2 and 3 pi over 2. But I want to narrow this in a little bit, and I want to go from, so I've got to set up my table. I'm going to start at 0, and then I want my little increments. I want to go, let's see, from 0 to, let's do an increment of 0.3. And then we're going to, we don't want to graph, well, you can see the graph. So those, if you ever see a vertical line like that, that's not actually part of the graph, that's the asymptote. Okay, so let's look at the table again. Let's see if that's enough. So if I scroll down in this table, doesn't really do it justice. The values from 1.08, I'm trying to get to a value of pi over 2, close to pi over 2. So, you know what, maybe even better. Let's see, so in my calculator, pi over 2 is equal to 1.57. So 1.57, I'm actually just going to ask. So this is another cool feature of your table. If you just ask values on the independent variable, then I know that 1.5708 is what it's close to. So this value, pi over 2, is 1.5708. It's approximately. So if I go to the left of that, just really close to that, I'm going to say, okay, so let's do 1.57 because that's a little less. What is that value? Whoa. See how big that value is, the output? So it's 1,255. That's way, way up here, right? That's beyond, outside of our graph. This only goes up to 8. So you get the picture as you approach this pi over 2, this vertical asymptote, your values are getting really, really big. Let's do negative. So if we did negative 1.57, because that would be approaching this asymptote from the right, that value is negative 1,256. So you can get the picture that it's the vertical asymptote it's approaching. So basically what I would recommend when you're trying to graph these is think of some nice numbers that we know. We know this is a nice number. This is a nice number, negative pi over 4. Wherever, in fact, it's pi over 4, you know that it's either negative 1 or 1. Remember, 5 pi over 4, it's going to be positive 1 again. So that's right here because the two negatives make a positive, the ratio, but it's 7 pi over 4 and 3 pi over 4. That's where we get our negative. So here's 3 pi over 4, here's 7 pi over 4. Once you have the shape, oh, and also when it's equal to 0. So when is the tangent of what angle would equal 0? Well, that's, remember, when you have 0 on the top, because that would be at 0. That would be at tangent of pi, because that's also the ratio of 0 over negative 1, which is equal to 0. Remember, ratio of tangent is just y over x. So that's at 0, at pi, at 2 pi, at 3 pi, at 4 pi, at negative pi, at negative 2 pi. So I'm trying to limit the time of my videos so they're not quite so lengthy. So I think I'm going to cut myself off here and have you guys read the section and look online. There's other lessons available. And remember, like I said, this is just an intro, but play around with these numbers. I do want to mention cosecant because that's kind of a neat graph, and secant, but I'll just show you one and then I'll be. So here's the graph of secant of x, and this is a crazy graph, and I actually I'm okay with providing like this basic graph for you, but I want you to understand where these asymptotes are coming from. Remember that secant of x is equal to 1 over cosine of x. Well, a beautiful thing, if you recognize these dashed lines, this dashed line, this graph right here, is cosine of x. And so they use that to graph it, because if you think about when cosine of x is, it's in the denominator here, right? So you can use that, and when cosine of x is equal to 1, you know that secant of x equals 1. And where is cosine of x equal to 1? When x is equal to, you can say 0, and when x is equal to 2 pi. Remember, cosine of x equals 1 here, and cosine of x equals 1 back here again, positive. Similarly, when is cosine of x equal to negative 1? Because that would give you the value of secant x equaling negative 1. So we just found this point and this point, right? And this point. So see how the dashed lines help you develop this. And then secant of x is equal to negative 1. Well, that would be here and here, right? Well, when is that for cosine? Because remember, secant of x equals negative 1. That's the same as 1 over cosine of x, which is negative 1 at x equals pi, and all the odd pi's, 3 pi, 5 pi, 6 pi, negative pi, so that's the only one they're going to show up here and here. Okay, your vertical asymptotes, think about that. Secant of x, it all goes back to cosine, so 1 over cosine x. So I actually might test you on this, so take that back. You can't, you have to memorize this and understand it and be able to develop it. When is cosine of x undefined? Meaning, in this case, when is cosine of x equal to 0? Because that's when secant will be undefined. And that'll give away your vertical asymptotes. So cosine of x is equal to 0 when x is equal to pi over 2. Look at the unit circle. Pi over 2 and 3 pi over 2. Okay, so do you see that that would give you a 0 in the denominator? All right, so secant x is undefined, we would say, when x is equal to pi over 2 and 3 pi over 2 and negative pi over 2. So that is how all of your vertical asymptotes. But look at this. If you look at the intercepts of cosine of x, see those, that's when cosine is equal to 0. That's a good heads up as to when your vertical asymptotes are. Okay, so here are your vertical asymptotes here and here. Okay, and then just a little knowledge, you can plug in some values, but you can see this is the graph because you have your vertical asymptotes. You know that this value is at 1, and then you can graph it just from the knowledge of it. If you did a table of values, you could look at that too. But let's just graph and show you how you would even graph secant of x. So let's clear this. Well, remember, secant of x is 1 over cosine, so we can always do 1 divided by cosine of x. So if you ever want to put this on your graph to check your work on this assignment, you can do that. Once again, those vertical lines, those are your asymptotes. So that is exactly what we have. And remember, I did my zoom trig, so I'm going from negative 2 pi to 2 pi. I hope this lesson was helpful, and I hope this section is helpful, and I hope you do go visit some links, the links I provided. If you find a better link or a better animation, please send it to me. Please share so we can share with the class. Okay, everybody, have a great day.